Is everybody ready?
Yes.
Okay.
For you.
No, I was waiting for you.
I'm ready.
All right. Well, anyway, this is me. My contact information is here. I also put it at the very end. And I'm going to try to move pretty quickly. I've got a lot of slides here. And I want to make sure I get to the last one because I want to make an important point on the very last, second to the last one. So moving along, see if this works. Advance. You said the right arrow is supposed to advance. No, it doesn't do a thing. This is the very first slide.
Try getting this space.
Can somebody come up and see if they can advance the slides? I cannot. I pressed the right arrow. No, you're doing something different. What are you doing?
You were just clicked onto the screen, so you should be able to go back and forth now with the arrow keys.
Show me.
Oh, it's just because the mouse was clicked on the screen. So you just,
I thought I would use these two keys.
yep, you're all good to go.
Oh, now you
Yeah.
got it to work.
Mhm.
I
You're all
hope.
good.
Let me try it before you walk away. Now it does work. A minute ago it didn't.
Yeah, because he has two monitors. He just clicked on one soon. So
All right. Anyway, this goes way back in time. I'm a believer that you should kind of learn from history as much as you can if you want to see what might be happening in the future, extrapolate from what people have done. If you lived in London in 1960, you might have seen this aircraft flying through the sky. They built one or two of them, and pretty heavy lifting, kind of a helicopter-like device. You know, it does not have a tail rotor. Most helicopters have a tail rotor to counteract the torque that gets put into the body when the rotor starts to turn. This one does not have a tail rotor. Anybody want to guess why?
It's a lot. Looks like an auto jump.
No, it's not an autogyro, but that's close. Say it louder. That's very close. It's actually got 4 rocket motors on the tips of those 4 blades. Now, when I say rocket motors, they've got a hollow tube that goes through the blades, and it forces compressed air with fuel out to the end of the rotor blades, and it gets ignited. So they've got a rocket flame coming out of the tips of all those 4 rotors. So there's no torque interaction between the body and the rotors. It's kind of nice that way. And it worked fine. But guess why it never got commercialized? Nobody liked it because, so on the next, look at the second bullet point. Great criticism was the noise the tip jets made. They couldn't tolerate the noise of this thing when it was flying around a city like London. So it never got funded, and it kind of disappeared in about 1962. So if they could have made this thing silent, it would have been a big winner. But no, they couldn't do that. Actually, it probably used a lot of fuel also. So that probably was the second reason why it never got anywhere. But we can learn from it. And I think that there's a way to electrify this. And I'm not going to go into the details of it, but if anybody's interested, I'd be happy to share what I think could be done at some future time with this general concept. Oh, I should also add, there are people right now in this country and in Sweden that are building and flying small versions of this that do indeed have propellers and motors at the tips of their rotor blades. So that works. The only question is, how can it be scaled up to make it big enough to be even more useful? So going on, so noise and economy was a major problem. This is a little later in time, but it's kind of a similar idea. It's got, and this is called a Carter copter. Oh, it was on the previous. At the bottom left, it has the Carter copter, which is extending the general idea, you might say. In this case, what they do is while this aircraft is sitting on the ground, they have an engine which spins up the rotor. But the rotor has a zero pitch, so it doesn't go up in the air. It's just spinning around. No lift from that rotor while it's sitting on the air, but it has a lot of energy stored. They get that rotor going as fast as they can. Then what they do is they quickly change the pitch on the rotor blades, and it forces air down, and the whole aircraft goes straight up into the air. Then what they do is they switch the power from the engine, from the rotor onto the pusher propeller. So now it's going forward. And then they could slow down the rotor. So it flies like a regular airplane, and it does have some wings. So the wings give it some lift, and it works. They made quite a few of these, but it never got to be a complete success. They designed a bigger scale version of this, but they never built this one. They were hoping to have like 6 to 9 people flying in this kind of an aircraft. Now, this technology that they developed was applied to a number of patents, and those patents got transferred to one of the aircraft that Todd was just talking about in the previous session or previous talk, and that was called the JAUNT, J-A-U-N-T. I'll go into more of that later. I have to go kind of quick because I don't want to run into the next talk downstairs. Going even further back in time, we have a patent from 1931, and this became known as a bucket drop method for lifting objects up from the ground straight up and lowering them down straight down again. Basically, you have this airplane flying in a big circle. Well, the circle should be as small as possible. And they have a long tether line, which has a weight at the bottom. And if they extend that line long enough, the cargo or weight at the bottom ends up on the ground at the center of the flying circle. They can then attach objects, little cargo or whatever, and the plane goes up, the cargo goes up, they reel it into the plane, fly off, and slowly lower it down somewhere else. Now, with a single airplane, this is not very good, because when you try to put heavier weights on the end of this cable, it really disturbs the aerodynamics of the plane to such an extent that this was never extended to any kind of significant weight for the cargo. So a small bucket and a Piper Cub, it works. When you try to do it bigger, it doesn't work. Now, guess what? This was 1931. In 1940, a man in Chicago found out how to solve the major problem. Not with one airplane. He's saying, no, you have to have 2 airplanes flying in a circle, and those 2 planes each have their own tether line coming down to a point near the surface, and then a single line coming down to a cargo container on the Earth. When those 2 planes fly upwards, everything goes up. The cargo goes up slowly. So this was at the beginning of World War II, and I'm sure the man had some idea of military application for this. But to explain this a little further, to get this to be even more effective, in addition to lifting it up, what happens is, if you look at figure 3, what you'll see is airplane B is progressing further around in the circle, flying faster and faster, and eventually airplane B catches up with airplane A. It takes about 5 revolutions before B catches up with A, and when that happens, they can both fly straight off. Looking at figure 8, they both fly off horizontally, high speed, long distance, better than a helicopter. Then they could go back into that orbit pattern and lower the cargo back down to the Earth again. So this was a concept that the man invented, but he, at the end of World War II, people didn't care about it anymore. He got another patent a few years later with some minor improvements, but it never got followed up on at that time. I think after World War II, nobody much cared anymore. So it was kind of forgotten until 1980, 1981. It could have been 1980, but I found no evidence at all of this idea being pursued between 1945 and 1981. Everybody just forgot about it. But somehow this man, Francis Wilson, working for Lockheed, thought it was a good idea. So he filed a patent. The patent was granted. And as you see here, 2 airplanes flying in a circle with tether lines coming down to a cargo. And the planes are going to rise up, the cargo goes up. So he actually got funding from probably through the combination of Lockheed and the Department of Defense. And so they had a team working on it to demonstrate it with real airplanes for the first time. And it wasn't easy, but they did it. You see figure 4 shows them flying off, pulling the cargo to some distant place. Now that cargo should be streamlined, so they minimize the drag of the whole thing. But whatever. Now, Wilson thought that instead of having to fly around 5 times before going off on a tangent, he was going to do it in just 1 revolution. So this is the pattern for what is called orbiting and deorbiting. That is, the deorbiting is the figure 2, where they're flying off at a kind of a tangent to the circle. The reorbiting is figure 3, where they're flying back into the circle to lower the cargo back down again. So a few years later, oh, I'm sorry, this was when the patent was granted. The patent was started in 1981. Also in 1981, it was actually demonstrated by the team tied in with Mississippi State University. And this paper was presented in 1983 at an AIAA conference, and it shows exactly what they did, how they did it, and it worked. However, it wasn't easy. It took them 31 tries to make the thing work. And so these are pictures from this paper from 1983. These are figures. Here's the airplane, one of the 2 airplanes that was used. This was a crop duster or crop spraying aircraft. And they had a fishing reel, electrically actuated, to lower the weight down to attach to the cargo. So 2 of these flying around the circle, and it actually did work. And after 1983, as far as I know, this idea was again totally ignored until, as far as I know, in 2006, a long time, from 1983 until 2006, as far as I know, this idea was ignored. But in some way or other, these 2 people in Australia thought it was a good idea. So they studied it and did some analysis of it and published this paper at the AIAA conference in Colorado. So you can read a little bit of the abstract, but basically It's the same idea, again, two airplanes in the sky lifting the load straight up. Now, in 2009, 3 years later, one of those two authors got together with a man named Wubbo Ockels, who is a Dutch astronaut. They together wrote this paper, which was even more significant and detailed. So they analyzed a very heavy aircraft lifting the load up. This is in the kind of the summary part of their paper. And what they say is, despite the considerable apparent value in developing a multi-aircraft cable pickup system, there is no publicly available technical literature that studies the dynamics of multi-cable systems for vertical pickup and delivery of payloads. Unfortunately, these several authors were actually not aware of the 1983 paper that had been published on this same topic. They were aware of the previous patents, but they didn't know that they were reinventing the wheel that was published in 1983. I think that's kind of interesting. Things get lost in history and then rediscovered again. So anyway, here's another figure from the paper by Williams and Ockels. Two aircraft, tether lines lifting a payload up into the sky. Now, interestingly, when you think about this, the two airplanes flying in a circle, normally they have to have a pretty significant bank angle. If you want a tight circle in an airplane, you got to bank it like at 40 degrees or something, right? Otherwise, to counteract the centrifugal force. However, when you have two tether lines, especially like back here, like here, notice those tether lines, when they're lifting a heavy load, they're under tension, but they're not going straight down. They're going at an angle. What that means is the tether lines are applying a force to the aircraft that you can separate into two components. There's a vertical force component, but there's also a horizontal force component. The horizontal force component from the tether lines counteracts the centrifugal force that's trying to pull that plane away from the center. Those two forces combine such that the airplane can fly with almost a zero bank angle in a circle, which means that the lift from those wings is pulling straight up rather than at an angle. I hope that's clear. So that's a pretty big advantage. Now here you notice in the top figure, this is bank angle as a function of aircraft orbit radius. You notice when you get out to a big enough orbit radius, the bank angle is close to zero. That's kind of nice. That's much better than you can do with the bucket drop idea with a single airplane. So these people analyze this for heavy loads. You notice the aircraft weight at the bottom where it says figure 6, they analyze it for payload mass going from 500 kilograms up to 10,000 kilograms. That's a pretty hefty payload. You can carry quite a few passengers with 10,000 kilograms. They did it for not only 2 airplanes, they also analyzed it for 3 or 4, lifting even heavier loads. Now, as far as I know, this idea that was studied pretty carefully in 2009 was again not picked up until a few years later, except that it wasn't for transportation. This is a company called Makani Power. Here it says Makani Energy, but the official name was Makani Power, a group of people in California that had been doing windsurfing. And in their windsurfing activity, they conceived that there's a lot of power, especially at with high altitude winds. So they decided to make a business out of it. And this is one of their earlier concepts. You notice this one has 4 propellers and 4 motors. And the idea is that this aircraft would be put on a mounting structure, and the propellers would be pulling the aircraft straight up. So there'd be the 4 motors pulling it up. When it gets high enough, it would go downwind, and it has a conductive tether line, and it was going to generate electricity for utility use when it would go high enough, fast enough. And here it is, tethered, flying up in the sky. Now, they were able to demonstrate this. Their company got acquired by Google, and Google had plenty of money, so they put a lot of money into it. They did a very detailed and complete analysis and demonstration of generating electricity from this aircraft flying downwind. This is a time-lapse photograph of the pattern of flight. Now, I do not believe a human pilot could fly in this precise kind of a circle. That would be almost impossible. But they demonstrated that with the computer control, navigation, sensing, and all, they get a very precise flying circle. As it turns out, I happened to be at a conference once at Stanford University, and in the hallway, I talked to the president of McCanny at the time, and I suggested to him, instead of only generating electricity with their concept, they should think about having 2 of these things flying in the same circle, and then lifting the load straight up and carrying it off to some other place and lowering it down again. You know, transportation. And he just kind of chuckled and walked away, and that was the end of that. And so at the present time, McCanny power is non-existent. They couldn't solve all the problems. A conductive tether line, thousands of feet up into the sky. What happened in a lightning storm? You know, not so good. So too many problems. They couldn't solve them, too expensive. That was it. I started at about the same time. I was looking into the dual aircraft lifting idea as compared with helicopters. And I concluded that dual aircraft was going to be quite a bit better from a fundamental standpoint in terms of economics, let's say. And well, this shows some economic comparisons. There's a company that does heavy lift single engine aircraft called Air Tractor. It's used for crop spraying and so forth. It looks like a P-51 Mustang, sort of. Well, I showed a picture previously of the 2 airplanes in 1981. But anyway, this kind of a graph shows that a helicopter, in terms of lifting a load, is much more expensive than a single wing aircraft. And so this gives more credibility to the dual aircraft lifting idea. Also, operating cost, fuel or whatever. The fixed wing aircraft is much better than a helicopter in terms of direct operating cost. So here's one of the airplanes made by Air Tractor, and they can lift up to 10,000 pounds. Pretty heavy lift. They can also fly slow enough to fly in a pretty tight circle. These are just some numbers for one of their aircraft. You know, useful load, 9,249 pounds. 2 of these would lift about that same kind of weight, I believe. So these are, I'm going to go over kind of quickly. Uh, Again, kind of comparing the idea of helicopters versus tier aircraft flying high up in the sky. Helicopters have had some problems and accidents from a brownout condition when they're flying in a dusty environment near the surface. Ballistic rescue parachute. So some of these can lift a pretty or heavy load. This one says maximum weight 5,690 pounds. So to make it safe, of course, you might want to have ballistic parachutes on the anything with people up in the sky. Okay, flight distance. That's also an advantage for the dual aircraft. Anyway, here are 5 things as to why it might be better to use 2 aircraft to lift a heavy load and carry it somewhere as compared to a helicopter. Number 1 is the load versus the cost. The cost to purchase. Number 2 is the cost to use. Cost per mile is much better for 2 fixed-wing airplanes. Noise. I mentioned that the noise was the biggest issue with the aircraft in England that we started with. If those airplanes are always far from the surface, the noise from them will be much lower. And fixed-wing airplanes can certainly fly a lot faster than a helicopter. So basically, if you think about it, if any of you know or remember the P-51 Mustang, if these 2 airplanes are P-51 Mustangs, they can fly at 400 miles per hour, and they fly 1,600 miles. Can you imagine any helicopter doing that? I cannot. So basically, this is, again, an idea that I think someday people will reinvent one more time. Only time will tell, but I think it could happen that way. Okay, now coming up to more current times here, there's a company named Pipistrel, which was founded in Slovenia, I believe. It was mentioned in the previous talk. And they had some early examples of electric aircraft that were pretty advanced for the time. Now, at the very top here, the 2 lines, this was 2007, 2008. It was the world's first 2-seat fully electric aircraft and the first electric motor glider to achieve serial production. And then down below, in 2016, Pipistrel ran the most powerful hybrid electric powertrain in aviation, etc. So they made some advances at that time. Now this brings it right up to the current time. This is a spreadsheet list. I know you can't read that very easily, but I have some graphs that show some of these numbers. But basically, this is a company in California called SMG Consulting, and they make it their business to keep abreast of the latest data and information about all of the electric aircraft that have some chance of being a real successful product. Now, this spreadsheet is organized according to what they call the ARI, AAM Reality Index. In other words, they're saying that the scale from top to bottom is a ranking of which companies and products they think will really be there a few years from now. The number 1 on the list is a company called Joby, J-O-B-Y, based in California. they've achieved almost $2 billion of funding for their activity. They're number one in terms of investor support right now. And number two is Volocopter, which was mentioned in the previous talk. Number three is a company called Archer. They're very close to Joby in California. So the two California companies are actually near the top of the list here. I'm not going to read all the rest of these, but there are some graphs that show up. There are about 30 companies on this spreadsheet. And you can see this if you go to the website at the top here, smg-consulting.com, you can get a current version of this spreadsheet. This one's from February. Can you read the bottom right? What does it say? Last month. So that's pretty current. A couple months from now, this will probably be updated. So if you want to see this at home, just go to that website and you'll see all of this information. So now, this is a graph which has the numbers from that previous spreadsheet. And at the left is Joby. You notice they're way out ahead in terms of funding from who's ever in second place. The second place aircraft that they list here, you probably can't read it, but it's called Lilium. It's a German company. They have a very unusual design. I'll show a picture of it later. Number three is Archer, second California company. Number four is a company you can drive to from here and visit and watch. They're in Vermont, near Lake Champlain, right across from the border of New York. So you're welcome to drive up there and see their plane, watch it fly, talk to the people in charge, and tell them what you think. Whisk, which is the orange one, the fifth from the left, is actually owned by Boeing now. They are very unique in that they're the only company in this large group that is doing nothing but autonomous control of their aircraft. They are not attempting to even have a pilot on board, even at the start. They're saying the world is going to be autonomous. They're going to design their aircraft that way. And since they're getting an early start, they'll be ahead of some of their competitors. So time will tell. So this is a graph showing funding ranking, you might say. There's some fine print at the upper right. I tried to magnify that to make it readable, but what they're saying is that some of the companies in the spreadsheet, like Airbus, Textron, Honda, and Volkswagen, they are corporate owned. And so we don't really know how much funding they might get. The corporate managers decide whether they, one year they want to put more funding or not. So it's kind of uncertain. So this is a graph which shows the estimated date of use by the public. The number one top on this list is a company in China called EHang. So you notice it says at the top 2023. That's this year. What they're saying, what they're indicating here is that if you go to China right now and have enough money, you might be able to buy a ticket to actually fly in an EHang aircraft. I'm not planning to do it, but you might be able to. That's the first one of this large group that they expect to fly commercially. Now, there are four others that are down the list: Alakai, Beta, Elroy, and Pipistrel, and Vodacopter. There are five that are expected to have their aircraft in service next year, 2024. Now you notice on the far right, some of them are marked with little red indicators and some green. What that means is you can't read the fine print right here, but when they put a red indication like here and here, it means that the people that are not within the companies have low confidence that they're going to succeed in these in-service dates. But when they have the green marks, it means that they're pretty confident that this will really happen in 2024, next year. Now, the most well-funded companies are in the next group down below that. You'll see there's Archer and Joby. Can you read this? Sort of? Sort of. This is Archer, this is Joby. So even though they're the best funded, they're not intending to try to fly until 2025, 2 years from now. But still, you can see there are a large group of companies that are intending to get their aircraft up in the air and in use within the next 2 years. That'll be a big thing. That'll be in the news quite a bit. So we'll see. I'm looking forward to it. Now, the company that I mentioned before, SMG Consulting, they have issued 5 predictions for this year for the AAM industry. AAM being Airborne Advanced Mobility. So number one is these companies will roll out what they call conforming aircraft. Archer, Beta, Joby, and Volocopter. Conforming aircraft, I guess, means that they're intending to have these eventually mass-produced, well-defined components, etc. Number 2 prediction, the EHang aircraft in China will have their aircraft certified for commercial flying this year. Okay, probably will. Number 3, OEM's funding will be lower this year than it was last year. Number 4, most of the 7 demonstrators expected to fly in 2023 will be delayed to 2024. Number 5, number of vertiports companies in the world will double. So instead of a heliport or an airport, you're going to go to a vertiport. Doesn't have a runway, but it's got a waiting room, it's got a place for recharging the batteries, all that sort of thing. Probably room for parking too. So here's the number 1 funded aircraft available from Joby, California. And it has 5 motors and propellers that can be rotated 90 degrees. When they're pointed straight up, the aircraft goes straight up. They slowly rotate them down to be horizontal, and the aircraft goes horizontally forward. And they reverse that process to come back down. Pretty straightforward, but they've got to have reliable rotation devices. This is their main competitor, also in California. They have rotatable rotors only in the front, not in the back. But they both have wings, so they can fly kind of like a regular airplane. Here's the one that's closest to us, as far as I know. This is an overhead view of the Beta Technologies aircraft. They only have 4 rotors and 1 pusher propeller. So it's kind of simple, but they've got a nice long wing so they can glide and fly to an airport. They're intending to have this aircraft certified as a conventional aircraft without the vertical lift, actually. And they expect to do that well before it'll be certified as an eVTOL, which includes the lifting propellers. This is the company owned by Boeing called Whisk, and they're doing some air taxi service trials in New Zealand. This is the Volocopter made in Germany. This has been flying probably for the longest time already, just onesie twosies with special permission, not commercial flying to take paying passengers up. But this is very reliable, pretty quiet. With a conventional aircraft, if you have one or two engines, and one or two of those engines fail, you're in big trouble. This aircraft could have three motors fail, and it still flies. If one of these motors fails, you probably wouldn't even know it. They've got 17 other ones that keep it going. That's called redundancy. But it doesn't go very fast because it does not have wings. But you can't have everything. This is the company in South America. Embraer is a pretty well-known big company that makes airliners, and they're also getting into the eVTOL business, and this is their entry into that. Also having wings, very similar to the one from Beta. This one has 4 lifting rotors. This one has 8, so twice as many lifting rotors and 2 pusher propellers shrouded in the back. This is one from Airbus, well funded. I can't quite count the number of rotors and motors on this one, but it's probably in the order of 8, I guess. The specifications are at the bottom. Oh yeah, it says propulsion, 8 propellers, 4 seats, range 80 kilometers, cruise speed 120 kilometers per hour. This is a company based in England. It's the only major one I know based in England. And you see what the configuration is here, similar to a few of the others. This is a cargo aircraft, Elroy. And Todd, our previous speaker, showed a picture of this also. And I believe that the cargo, in this case, the cargo container at the bottom is removable, and then they can move the cargo to wherever they want. But I was thinking that that cargo container is probably 6 or 7 feet long. So that's about the same size that I would require if I'd lie down flat. But if they want to fly me somewhere, I'd want to have some portholes to look out. So that it would be a passenger aircraft for one passenger, right? Anyway, here's another. I mentioned Pipistrel. They're getting into the business in the cargo area here. Again, it's pretty small, but it has lifting propellers. So it'll go straight up, and it's got wings, so it'll go pretty fast horizontally. This is Autoflight, a company that's based in Germany. And this is kind of similar to quite a few others of the in the big list that we were showing. Okay, this is an unusual aircraft. The company is based in Massachusetts, and they're intending not to have batteries. They've got hydrogen power. So we'll see how that works out. But it's one of the few that is trying to do it with hydrogen. This is a company that's one of the major automobile companies, Hyundai, and they have this aircraft they're calling Super Now. They're exploring eVTOL operations in Miami, it says here. So we'll see how that works. This is one of the EHang ones that's supposed to be flying this year. You see specifications on the bottom there in terms of size, weight, and speed. You notice it has, let's see, I think it probably has 16 motors and propellers. So if one or two of those 16 fail, it'll probably still fly. Again, pretty good redundancy. You better not get in or out of this aircraft until you're sure those rotor blades have stopped turning. This is a one-of-a-kind design from a company in Germany called Lilium. And Lilium is very well funded, but the experts in the field are not yet confident that this is going to be a long-term success. It looks very futuristic, and they are flying some, but and the way this works is they have like 30 or 40 little electric motors and propellers, ducted propellers inside the enclosures on the wings, so they can rotate those 90 degrees, and when the airflow is vertical, the thing goes straight up. When the airflow is horizontal, it flies like a winged aircraft. So it does work, but I think the power density for those motors is so high that they cannot hover for very long. They've got to very quickly convert from hovering into horizontal flight. Otherwise, those motors are going to overheat and the thing will fall back down to the ground. This was another aircraft that was mentioned in the talk previously. I'm just showing two examples here. The top example is when it's flying high speed horizontally. The bottom example shows the configuration for hovering and vertical takeoff and landing. This, again, I believe this is a California company. We'll see how well they do. Here's another company in China. Geely, is it Geely or Geely? I don't know. But that's a predominant automobile manufacturing company. And they're getting into the eVTOL business as well. So this is their design for it, very similar to many previous designs. Okay, this is, again, a one-of-a-kind design, the Jaunt Journey, it's called. And we covered that. They took over the Carter copter patents. Oh, there's a question. Go ahead. No, behind you.
Do you have if these designs that have 5 to 17 hold up better items that keep a helicopter?
I think they'll probably be better, but that's not a subject I know a lot about. The previous speaker could probably answer that question a lot better if you catch it. Yeah. Go ahead. You said rain?
Range.
The range? They all have specific. Pardon? Well, yeah, they each have their own specification on how far they can go, and this is always a trade-off, you know. So it's not an area that I've studied a whole lot, but I think the previous big spreadsheet might have had that as one of their parameters. I'm just going to go back and see. If you want to learn about the range of any of these aircraft, I would suggest you have to either find it in Wikipedia or Google, and it'll give you those numbers. But I don't really have a comprehensive answer about that question. Yeah, go ahead. Yeah.
Is that fuel cell thing?
I believe it is.
Okay.
I believe that's a fuel cell concept. Yes, it wouldn't have to be, but I believe that is correct. How am I doing on time, by the way? How much time do I have? Pardon me? And when is my ending time? Oh, well, I better end quickly, right? Okay, I'll try to wind this up. There's not much more here that's of any significance, actually. Okay, here's another kind of an unusual design. This company is based in Germany, and you notice they have ducted fans in the wings. Here's something kind of bigger. This is not an eVTOL. This is an electric aircraft that requires a runway. But you notice the runway requirement is 300 feet. Have any of you ever taken off in an airplane that has a runway of 300 feet? Maybe not. But anyway, they do this because the motors pushing air over the wings gives a very significant lift on the wings, even though the aircraft itself is not moving. That's the idea here. It's called lifted, or no, it's called blown, B-L-O-W-N, blown wings or blown lift. Anyway, here's another very nice looking aircraft that is all electric. They've changed their headquarters location from Europe to Arizona to now I believe it's Washington State. But they're flying this. This talks about their maiden flight. Something even bigger, based in Sweden, electric powered, hybrid electric. I believe the hybrid means that they do have hydrogen as a fuel source as part of it. Oh, here's the one and only seaplane. If you live near a lake, you might want to buy one of these when it's available. This company is based in Massachusetts, Boston. So if you drive up to Boston, you can talk to these people and try to get a ride in their seaplane. All electric. Now, if you like something a little smaller, if you like motorcycles, you would like this. It's one passenger Jetson, based in Sweden and Italy. You notice it does have a ballistic parachute, so you'd probably be pretty safe. They're flying these. These will be delivered this year without any doubt. They used to have on their website a list of their earliest customers. Some are based right here in New Jersey, actually. So it may be that sometime this year you'll look up in the sky right here in New Jersey, and you'll see one of these flying. Here's another one. This is based in Ohio. Again, single passenger, but they've got so many motors and propellers that if one of those fails, it'll still fly. Not very fast, but it'll fly. And they're flying this in Las Vegas in a previous time. Well, this is my final slide. I want to make one important point. Look on the bottom, you'll see some of the fundamental differences in the designs of these. There's a lot of safety factors. The one on the far left, volocopter or multicopter, they've got so many propellers and motors that if any one or two fail, no problem. It'll still fly just fine. I want to make a point about the second one from the left. That is like the Beta Technologies design, the one in Vermont. Think about this. If you fly in almost any airplane today as a passenger, whether you're in a Piper Cub, a Cessna, twin engine, or big passenger plane, there's only one way to get back on the ground safely. And that one way requires it has two requirements to get on the ground. You've always got to have enough speed to have lift from the wings. If you go into a stall, going up too much or whatever, not enough speed, the wings don't have lift, you're going to go down, whether you want to or not. That's a constraint. Another constraint is you better find a flat space on the ground to go down to. If you don't have an airport or a flat enough space to land your plane, nothing but rocks or trees, you're still in trouble. Unless you have those two things going for you, you might not survive. Guess what? This second from the left plane on the bottom could be designed so it has not one way to get down safely, it has three ways to get down safely, three independent ways. And here's what I'm saying. They could design it so the battery and the control system for the vertical takeoff and landing, that is the four propellers and motors doing the vertical motion and hovering, could be independent from the pusher propeller at the back and the wings. So basically, if either of those systems fails, the other one can do what's needed. So basically, those are two fundamentally different ways for this aircraft to get on the ground safely. It's also small enough so it could have a ballistic parachute. So even if there's an airborne collision and it loses one of its wings, no problem. Push a button, the ballistic parachute pops up, it floats down to the ground, no problem. So instead of only one way to get down safely, which you have, now there's one exception to the conventional things today, and there are a few small aircraft that do indeed have ballistic parachutes, but not a very, very big percentage. So I believe this kind of an aircraft will be extremely safe. I would not have any qualms about going up in one of those. So that's all I have. Thank you very much.